Hello everyone. The purpose of this video is to go over the review for the exam. First of all, make sure to go to unit number 1 because the exam will cover unit number 1, which entails chapters 1 to 4. So if you click on week 2, since we are in week 2, and you click on the exams, you'll see the information about the exam, coverage, and the time window to take it. Here you can find the formula sheet that you can use during the exam. Of course, the exam is open book, so you can look at the book, but of course, keep in mind that you have very limited time to take the exam. Yeah, so this is exam 1 review. Click on it. And let's look at the items here and what they represent. So I'll go quickly over some of those questions with focus on the concepts. Item number 1, in a friendly game of a handball, you hit the ball essentially at ground level and send it toward the wall with a speed of 23 meters per second at an angle of 30 degrees horizontal. So let's look at what we are given here. So this is the X and the Y. And this is the origin, 0, 0. V0, which is 23 meters per second at an angle of 30 degrees above the horizontal. And notice every student will have different values. So 23 meters per second for one student might be 30 or 20 or 15 or 60 meters per second for another student, as well as the angle will differ. Each time you attempt to take the test review, you'll get different values. Okay, so let's look at X and Y direction. This is a projectile. The information we have is the initial velocity. So we know that the initial velocity in the X direction will be 23 meters per second, cosine the angle, which is 30 degrees. We have the velocity in the X direction. We don't have any information about the final velocity or the velocity at any moment after t equal to 0. We are not given any information about the time, and the time between X and Y will be the same. As it moves in the X direction, it moves simultaneously in the Y direction. Remember, the X and Y for projectiles are moving together. There's X component and Y component at every moment in the projectile motion. We took the initial position to be 0 in the X direction, and in the Y direction also the initial position is 0. We have no information about the position at any moment after that. Okay, now how about the final position? Now regarding to X, we still not have information. How about the acceleration in the X direction? Now we know the acceleration in the X direction is 0. Why? Because there is no force, there is no influence on the projectile while in the status of free fall. And in the free fall problem, there is only one acceleration, which is the vertical one, the acceleration due to gravity. The horizontal acceleration is 0. So AX, or the acceleration in the X direction, is 0. Initial velocity in the Y direction will be 23 meters per second, which is the initial velocity. Sine the angle, sine 30 degrees. Now again, also the final position is, we have no information from, at least from the statement here of the problem. And the acceleration in the Y direction, we know it's 9.8 meters per second downward, and we can take downward to be negative if we take upward to be positive. The same thing, we take to the right to be positive, therefore to the left will be negative, and this is arbitrary. If you take up to be negative, then down, the downward direction will be positive, and vice versa. You just need to be consistent, that's the main thing. So here the acceleration is negative 9.8 meters per second square, which is g. All right, so what are we asked to find? We are asked to find the time it takes for the ball to reach the wall if it's 3.9 meters away. Now, what does 3.9 meter represent? It's the distance. So the wall, if this is the wall here, so this is our x direction, and we are going to draw the wall here, and apparently it will hit the wall, which will be at a distance of 3.9 meters. We don't know exactly where will it hit the wall, but we know that the distance here, distance from here to there, is 3.9 meters. Okay, so what does 3.9 meter represent? It will hit the wall. Let's assume it will hit the wall here. I don't know exactly where, but let's assume it will go through this motion and it will hit the wall here. So 3.9 meter represent what? Think about it. It represents the final position in the x direction. It's not the final position in the y direction. We don't know what is the side. This will be y final, whatever y final is. So the 3.9 meter represent the final position in the x direction. So this is 3.9 meters from question A. And we are asked to find the time. And the time, of course, is a common denominator between the x and the y motion, meaning at the same time it's moving the x, it's moving also in the y. Unlike acceleration, which is different between x and y, time is always the same. So we need to find the time. So what should we use? Should we use the x direction or y direction equations? Now, if you look at the equations here, okay, those are the equation in the x and y direction. We know we'll be able to find v0x and v0y initial position and the final position. We know that the final position is 3.9 and the initial position is 0. So delta x, which is the displacement in the x direction, is 3.9 minus 0, which will give you 3.9 meters. And we know the acceleration in the x direction is 0. The acceleration in the y direction is negative 9.8 meter per second squared. So which equation has time and also all the other variables are known? So we are looking for an equation that contains the unknown, which is time. So we are not interested in equation that does not have time, like this equation. Equation number 5 would not help us. We're asked to find time, and equation number 5 has no time. So we need the equation that has time and all the other variables are known. Now, for example, this equation has time. We know g, we know the initial velocity in the y direction, but we don't know the final position in the y direction. We're not given any information about the position at which the ball will hit the wall. So we cannot use this equation. The same thing, anything that has y would not help us because we don't know the final position in the y direction. We know the final position in the x direction, which is 3.9, but we have nothing in the y direction. And we know we have nothing about the final velocity in the y direction, the velocity at which the ball will hit the wall. So this would not help us. Neither does this because it has y. So the equation in the y direction will not help us. Now let's look at the equation in the x direction. Now remember, in the x direction, in the case of projectile, the acceleration is 0. So anything here that has acceleration, we can replace it by 0. Okay, here the acceleration is 0, but of course, this one does not help us. Here also the acceleration is 0, but this one does not help us. We need an equation that has time in it. Okay, so this equation has time. And we can see here that the change in the position, which is displacement, is equal to the initial velocity times time. Okay, so we can use this equation to find the time. So now let's go back. Now, how about this equation? This equation is the same as this equation because the average velocity will be the initial velocity in the x direction. Since the final and the initial velocity in the x direction will be the same. Why they are the same? Because the acceleration is 0. So there is no change in the horizontal velocity. Okay, and this equation also will translate into this equation. Okay, so this is our equation, x, the change in x, which is the final position minus the initial position, equal to the initial velocity in the x direction times t. Now we know that the x, as we mentioned, is 3.9 meter minus 0, so 3.9 meter, equal to the initial velocity in the x direction, which is 23 meter per second cosine 30 degrees times the time. Okay, and now we solve for the time. The time will be, of course, you multiply both sides of the equation by 1 over 23 times cosine 30. This will yield 3.9 meter over 23 meter per second cosine 30 degrees. Okay. Meter here will cancel out with meter. You'll get the answer in 1 over second, which is second, right? 1 over second is a second. Okay, now let's carry out the calculation. So I'm going to use the calculator here. And make sure, by the way, that your angle is set at degrees, not radian. Okay, make sure it's not radian. This is the radian here. Make sure it's set at degrees. So we've got 3.9 divided by, and then open parentheses. And we'll have 23 meter per second. So 23 times cosine 30. And then press enter, and this will give you the time in seconds. So the time came out to be 0.19579. So we need to round it off to 2 significant figures. So this will be basically 0.20. Let's see if we are going to get the right answer here. And you can see that's the correct answer. Again, guys, remember each one of you will get different values. So make sure you solve it based upon the values you have. Okay, in part B, it asks you about the value, the final Y. So how high is the ball will hit the wall? So now if you go back here and write the information we are given to figure out the equation we need to use an equation that has Y. So let's look at the list of the equations here. We need an equation that has Y. So we are focusing now on those values here. We have this equation. We have this equation, but the problem here, we don't have the final velocity. We have information about the time. Now we know the time. This equation does not help us because, again, it needs the final velocity. Remember, V average represent the final velocity plus the initial velocity. I'm sorry, the initial velocity plus the final velocity. And we don't have the final velocity in the Y direction, okay? The same thing, we can't use this equation. So any equation that has final velocity will not be able to use it. So we have only this equation to use. Remember, this equation is the same as this equation. The only thing is just moving Y to the other side here. Y minus 0, we know the initial position is 0, equal to the initial value in the Y direction. We know the speed is 23 meter per second. And angle, we know that the initial velocity here is 23 meter per second, and we know the angle is 30 degrees. The projection on the y-axis will be the y component of the initial velocity, and it will be 23 sine 30 degrees because it's the opposite to the vector. So we're applying this equation here. So V0y will be 23 meter per second sine 30 degrees. This is the initial velocity in the y direction times t minus 1/2 g, which is 9.8. Of course, we don't need to include negative 9.8 because the negative is already incorporated here, times t squared. Okay, and we need to solve for y. Okay, so y is equal to, now the value of t is already given to us. We found it in the previous part, which came out to be 0.20 seconds. So we don't need to write it as t. We can replace it with its value. Change here. So this is times 0.2 seconds minus 1/2, and this will be 0.2 seconds squared. This is 0 whole square. And now we need to carry out the calculation. Okay, so we're doing it in one step here. So open parentheses, that's 23 meter per second times sine, and the angle is going to be 30 degrees times the time, which is 0.2. We'll close the parentheses, and that's minus 1/2 gt squared. So open parentheses, 1/2, which is 0.5 times 9.8 times t squared. So it's times 0.2 times 0.2. And I'll close the parentheses here and press enter. We got the time, and we got the displacement in the y direction to be 2.104. So let's input it here into our answer in part B. We're asked to input two significant figures. So we'll take 2.1 and we'll see how it will. Okay, and that's correct answer, 2.1 meter. Okay, so that's for this first question over projectiles.